Good evening, everyone, and welcome to a Reactor Sydney live stream. For those of you who are joining from elsewhere, good morning and good afternoon. Just a few things before we get started. If you do have any questions for today's session, we do have a Q&A box and we'll be asking questions to David at the end. And the session will be recorded and shared on our YouTube channel as well, and I can share that link in the Q&A for you. So without further ado, I'm going to hand you over to David, who will be running you through today's session. Thank you, David.
Hi, everyone. Natty, you can hear me okay?
Yep, I can hear you well.
Awesome. All right. So hi, everyone. My name is David Goad. I'm the Chief Solution Architect at the Automation and Innovation Hub at the Sydney University. I'm also what they refer to as a Microsoft Regional Director. The title of today's talk is Transparency and Algorithmic Decision Making, pulling back the curtains on artificial intelligence. Let me see if I can get my... So just to introduce myself a little bit further, as I said, I'm the Chief Solution Architect for Automation and Innovation Hub at the University of Sydney. I'm a Microsoft Regional Director. I'm also a fellow at the University of Sydney. I teach digital transformation. My research areas are automation, artificial intelligence, and the Internet of Things. I'm also a lecturer at digital innovation and digital strategy at the Australian Graduate School of Management. And I present and do workshops and sessions around AI, IoT, blockchain, AR, VR. If you want to connect up with me on LinkedIn, then feel free to use that QR code, or you can just do /IM/Dcode is my LinkedIn profile. So the agenda for the topic for today, this idea of transparency, algorithmic decision making, and this how technologies gain legitimacy was actually the topic of a research paper that I did about 2 years ago. So today's conversation is going to be partially from that research paper that I did, which for those of you who are interested, I can actually give you access to that research paper separately. It's a published research paper. So it's partially based on that and partially based on practical experience. So aside from being an academic and teaching technology to business folks, I also am a practicing consultant. So as the Chief Solution Architect for the university, I've deployed quite a few artificial intelligence projects over the years, and I've also helped a number of clients outside of the university deploy them. So it's based on sort of my practical background and practical learnings. So in terms of the agenda for today, it's going to largely be as follows. I just want to set the scene a little bit and point out why I think this is an important discussion, why transparency, particularly in terms of ADM, is important, not only for organizations, but for people in general. I want to talk a little bit about what algorithmic decision making is, or AI is, and the underlying technology. I'm going to talk about some of the concerns and challenges that people have expressed with deploying algorithmic decision making, or AI specifically. I will also spend some time defining to you what I mean by algorithmic decision making and artificial intelligence, which is a subcategory of ADM. I'm going to talk about this concept of transparency, how it's becoming more and more important in people investing in the conversation. Some large organizations, like, for example, DARPA in the United States, the Defense Research Organization for the US military, are investing heavily in AI. And I'm going to talk to you a little bit. I'm going to set a little bit of a framework, not too much, but a little bit of theory around transparency and legitimacy. And this concept of legitimacy is important because it brings it back to this issue of change management within organizations, and how organizations, when they adopt technology, can gain acceptance around that technology, which is really important, because for any organization, whether it's government, corporate, whatever, you operate in the context of what society accepts. And if you cannot gain legitimacy for your actions or how you behave, then society will correct for that. And that's one of the issues that a lot of organizations are facing these days. And you see this all the time, for example, around sustainability, where a lot of shareholder groups are becoming much more active in forcing companies to have a sustainability plan to become more sustainable and worry about the environment. So if, as an organization, either government or corporate, you do not ensure that what you're doing is perceived to be legitimate in the public theater, people will force you to comply one way or another. We'll talk about this concept of how does technology gain legitimacy? How do people start to accept it? So we'll talk about this process of technology legitimation. And then we'll talk about the complex relationship between transparency and AI legitimacy. How does transparency both improve acceptance of artificial intelligence, but also in some cases actually reduce the acceptance? And what are the moderating factors that may impact that? And then I'm just going to give you a few sort of practical learnings. So this is, I'll take my academic hat off and put my consultant hat on, talk a little bit more about what organizations can do to get both their employees and their customers and society to accept what they're doing from an artificial intelligence perspective. And then at the end, we'll do some conclusions, and I'll give you guys an opportunity to talk about, answer some questions. I'll answer some questions for you. So setting the scene, we have a world with an explosion of data. By most estimates, the amount of data that's been produced in the last 18 months is equivalent to the amount of data that's produced in the whole history of man. It's projected by 2025 we'll be creating something like 163 zettabytes. That's 1 billion terabytes or 1 trillion gigabytes of data globally each year. As I'll talk about in a minute, we as human beings are just not good at managing large amounts of information. For example, I'm a member of the Royal Fire Service. I'm a deputy captain there, the Royal Fire Service in New South Wales in Australia. We talk about the rule of 5. There's 5 firefighters to every deputy captain. There's 5 deputy captains to every captain. There's 5 captains to every group captain. The reason why the RFS came up with the rule of 5 is because we as human beings can't handle more than 5 pieces of information in our short-term cognitive memory at any given time. So if we can't handle more than 5 things, what does that mean when we have all this data and all this information? We just become very poor decision makers because we just get overwhelmed. What that has meant is that algorithmic decision making, or using computers or machines to make decisions, is increasing because human beings are just getting worse and worse with those volumes of data, the velocity, the variety, and the volume of data that's coming at them. And artificial intelligence, which is a form of algorithmic decision making, has been increasing in use as well. But there are a lot of concerns that people have about this and how these machines are making decisions, not just about how we get from point A to point B or how do we operate in our daily lives, but these machines, these algorithms are starting to make a lot more decisions about people. And people have concerns about, machines making decisions about them. So, we'll talk through this, but it's one of the issues that drives this concept of transparency. One of the things that I put forward in this research paper that I published, and what I've observed practically over the last several years that I've been involved in deploying AI-based solutions, is that a lot of the issues that people have are affected by the transparency of how these technologies are deployed and applied. And so if organizations have a better understanding of the transparency in terms of how they are deploying these solutions and how visible they are to not only their employees, but their customers and the general public, it will have an impact in terms of their acceptance. And so, as I said, the focus of today's session is the discussion around artificial intelligence, algorithms, and the transparency and how that may affect, in terms of how they operate, that may affect their legitimacy, their acceptance by the general population. And we're going to ask a question. I'm going to ask the question and answer the question, hopefully to a certain extent. Does increased transparency increase people's acceptance of artificial intelligence? And I think what we're going to find is in some cases it does, and in some cases it doesn't, and I'll talk about that. So just to be clear and just to make sure everyone kind of understands what I mean when I'm talking about algorithms, artificial intelligence, machine learning, neural networks, these are all terms that are thrown around. And to be frank, I find that people oftentimes get confused by them. They misunderstand them. There's a lot of confusion out there in the market. So I just want to take a couple minutes and sort of provide some definitions. The first thing is, what is an algorithm? This is basically the idea that you're using a computer program to automate a decision-making process. For those of you who've had any kind of exposure in terms of IT, the basic programming, your if-then statement, your do loop, if this happens, then do that. That's an example of an algorithm in its most basic form. Artificial intelligence can be considered to be a subset of algorithms. This is the idea that you're building computer models that represent reality to allow machines to act more like humans and to interact with us in more human-like ways or more natural ways. And so artificial intelligence solutions allow machines to deploy some form of reasoning. They allow them to do some form of understanding, for example, in terms of natural language processing, conversational agents, and they allow these machines to interact with us in more and more natural ways. A subset of artificial intelligence is this concept of machine learning. This is the idea that you're building a mathematical model to represent reality, and that mathematical model allows you to build machines that can have a form of artificial intelligence or to act more like humans. So you're building these mathematical models, and one of the things, core assumptions in terms of AI, is that history is a good indicator of the future. You're building a mathematical model based on how you've seen something work to predict how it will work into the future. And that's a critical point when people think about artificial intelligence, because the question often is history a good indicator of the future in terms of how to make decisions? Within machine learning, there's a form of machine learning referred to as neural networks. This is where you're using mathematical models, as I said, to represent reality. But in this case, these mathematical models are based off the design of the human brain. So most people know that the human brain is made of neurons. These neurons fire off electrical impulses, and depending on how those electrical impulses fire and combine, it gives us consciousness. So years ago, and I mean years ago, back when I was a young engineer, we were talking about neural networks way back when, and I won't tell you how long ago that was, but it was a while. People thought, well, maybe if I build mathematical models that are similar to the way the human brain is designed, I can, build more powerful, machine learning tools, more powerful models. And so this is where they came up with the concept of neural networks. And then deep learning is a form of neural networks where just the depth or the number of layers of that neural network are quite large. So that's just a bit of the definition. So algorithmic decision making, within that artificial intelligence, within that there are different types of AI, including machine learning, and within machine learning there's different concepts like deep learning and neural networks. Now, ADM applications and their underlying technologies, right? The reality is that we have been using algorithms to run our lives for years. Again, I won't tell you how long ago this was, but one of my first jobs was, believe it or not, back in Canada as a nuclear reactor safety engineer. And I can tell you that all the nuclear reactors were run by very, very simple computers that were using algorithms to automate the management of these reactors, to make them safe, to power them down if there was a safety issue, to protect people, right? So we have been relying on algorithms not only to provide our power and to run our lives, but also to keep us safe. Another great example of algorithms that are used every day that get us from point A to point B and keep us safe is the autopilot in a plane, right? So there's a statistic that the majority of flying time that, before COVID, obviously, that was spent where people were traveling was done on autopilots. The pilots would take the planes up in the air, and then when they were traveling from point A to point B and sitting there for 15 or 20 hours in the air, they put it on autopilot and they'd sit there and just watch the computers. So these algorithms have been running our lives for years and doing it safely. So in some senses, the nervousness that people have around algorithms, I mean, we've been using them for a long time. It's more about the fact that in the last, I would say 10 or 15 years, it's become more obvious that we're using these algorithms, that we're using these AI tools to run our lives. And it's that obviousness of it that is causing more concerns, I think, for people in general. But why are we using more ADM and why are we using more AI? Well, obviously increased data, as I said. AI is not a new concept. It's been around for years. It's been around since World War II when Alan Turing came up with the Turing test and developed a computer to try and crack the Enigma machine, right? But why is AI, particularly in the last few years, becoming more popular? Well, first of all, we have all this data, and we know that the more data you have, the better an AI gets in terms of making decisions. The worse the human gets, but the better an AI gets. Second, because we have this massive on-demand parallel compute power and storage, that allows us to be able to process these really complex computer models. So the advent of cloud computing over the last few years has really furthered the ability to produce AI models and algorithms in general that can make more decisions, that can understand human language and do various other kind of interesting things. And then the last reason why ADM and AI specifically has become more popular is just because the math's gotten better. So these couple of graphs on the right are ones that I normally show. If you want to sort of measure how people are progressing in terms of AI technology, you watch, there's a number of sort of global competitions that the technologists compete in to basically build the best AI tool, the best machine learning algorithm to do things. So in the case of one very famous competition is ImageNet, where every year data scientists compete to see who can build the best AI to recognize images. And if you look at this graph, you can see that particularly in the last few years, machine vision, or using AI to recognize photos, has actually gotten more effective, or has a less of an error rate than human vision. The bottom right chart, speech recognition, you can see that same thing, where speech recognition is getting more and more effective. One of the things I should point out is that if you look at the two charts, you'll see, and you actually look at the percentages, you'll see that, for example, machine vision is probably more effective than speech recognition. And this is an important point to understand, particularly with AI technologies. They're not all created equal. Even for all the vendors, depending on the type of AI that you're talking about, they're going to have a better error rate or a worse error rate. The other thing to understand when you're talking about artificial intelligence is there's a number of different types of AI. There's what they refer to as AI, or unsupervised learning. That's where you're looking for patterns in the data. Then there's what they refer to as supervised learning, and this is probably the most common form of AI. This is where people are actually teaching the machine how to think. So I give the machine data, I tell it the inputs, I tell it what the outputs are, and the machine learning model basically develops a model that maps those inputs to predict those outputs. So we're supervising. The term supervised learning comes from the idea that we supervise the teaching of the machine. The unfortunate problem with that is, of course, if we have biases in terms of how we put learning into the data, or how we present the data to the machine, if we have biases in terms of how we perceive the world, then we as human beings can impart those biases onto that supervised learning. So that's one of the things you have to think about. And then probably, to me, one of the more interesting forms of AI over the last few years is really coming to the forefront is this concept of reinforcement learning. This is this idea of exploit versus explore, where you build machines that actually can learn from their environment. They try different things, and depending on those different things, they build a model for themselves in terms of how the environment will work. And based on that, they optimize the model and they optimize their environment. And if you think that's far-fetched, there are actually quite a few businesses, and for example, Australia at the moment, some of the large mining companies and chemical processing companies, they're actually using reinforcement learning to manage their manufacturing processes. So it is a technology that is an application right now. But one of the things you have to recognize is that in terms of AI, not all the criticisms apply to AI. For example, bias uniformly apply to all the different types of AI. So when you're having a detailed discussion about artificial intelligence, you really need to understand the type of AI you're talking about, and then that will lead to a more effective discussion around what are the strengths and weaknesses and issues associated with that form of artificial intelligence or algorithmic decision making. Why are people using AI? There's lots of reasons. Obviously, automating repetitive or manual tasks is a big one. This also leads to, as an aside, one of the biggest concerns that people always voice, and I hear there's a lot of fear, uncertainty, and doubt around artificial intelligence or algorithms replacing jobs. The reality is there's a lot of studies that show that the amount of job losses associated with AI and algorithms will be quite small. That's largely due to the fact that most jobs have some form of task or activities that can be automated, but very few jobs have 100% of tasks that can be automated. By some estimates right now, according to McKinsey Group, only about 6% of jobs globally could be fully automated with AI, but they'd be a very expensive proposition. So automation, is certainly an opportunity, but it's not as drastic or game-changing as people think. Probably one of the biggest things that AI is being used for is to improve the customer experience. The idea here is that if you can build models that predict consumer behavior, that predict the consumer, that take into consideration a whole bunch of information, then we can provide more tailored offerings to that consumer. And so this is probably one of the more interesting applications of artificial intelligence or algorithms in general. How do we provide a more improved or tailored customer experience? And then you have other things in here like reduce costs, augment complex tasks, which is very common, the way to start out with AI, and other things as well. So what are the concerns and challenges about deploying algorithms? Well, there are a few. Some of the challenges with AI, well, obviously, if you're getting a machine to make a decision, an algorithm or artificial intelligence tool to make a decision about data, and the data quality is bad or poor or inaccurate, or there's a problem, then it's going to make a bad decision. So one of the things you have to worry about when you're putting in algorithms and AI tools is that you have good data quality and that you're constantly managing that data quality to make sure that the machine is making the right decisions. Because if, for example, the AI is making a decision about some data that's sitting in some business system and someone upstream of that business system decides to make a change, which either corrupts that data or changes the basis of the analysis, then the AI will make bad decisions. So it's data quality is not a state, it's a process that's ongoing. This idea of self-fulfilling prophecies, there's been a lot of talk about this idea. For example, there's a very famous example in the United States where law enforcement were using artificial intelligence tools to predict where they should look for crime. The challenge there is if you tell people where to look for crime and they look for crime and they find crime, then there's a bit of a self-fulfilling prophecy and people start, the model proves that it's worked, but you don't necessarily look in other areas. So you have to be careful that you don't have these self-fulfilling prophecies when you build AI tools. Model complexity. If we talk about this idea of transparency or being able to understand how an algorithm or AI works, opacity or not being able to understand that is the opposite of that, and model complexity adds to opacity or opacity. What I mean by that is that, for example, several months back, I built a simple AI to categorize some photos. That was based on a neural network, and I reckon it had over 100,000 different nodes in it. I couldn't understand the model. I knew that the model was accurate, but I didn't understand how it was making the decisions. And this is one of the challenges with artificial intelligence, that the model complexity, the models that we're building are so complex that human beings can't understand them. And if we can't understand them, we can't, dissect why the machine is making these decisions, which is a problem. And then just the breadth and variety of data that's being used to make these decisions. As we'll talk about in a minute, some legislators have actually put laws in place because they're concerned about the data that people are using to make decisions about people, and this is a concern. You also have, there's been a lot of increased media attention around the use of AI in various sectors like health, transportation, and the military. And there's a couple of really interesting books that you can read that basically talk about the negatives around algorithms and AI. For example, the one that I would probably recommend the most is by Kathy O'Neill. She did her PhD in math. She went to work for the big financial banks, financial firms and banks, building models to predict stock prices and various things. She goes through a litany of different examples of where people have used AI badly, where they've used algorithms badly and it's had a really negative impact on human beings. The Black Box Society by Frank Pascual is another book that talks about the challenges with use of algorithms. It's a little bit more, I would say, negative. Both books are negative. I guess what I'd say to you is if you're interested in AI or algorithms, reading these two books will give you sort of a really good perspective on what not to do when deploying algorithms or artificial intelligence. And AI, but the thing is AI is being used all over the place in a variety of different industries: healthcare, manufacturing, financial services. For example, some of the fastest selling consumer products, smart speakers, right? Google Home, Amazon Alexa, are powered by AI. Number one selling consumer items in the last couple of years. So AI is definitely, both from a business perspective and a consumer perspective, coming to the forefront. So this issue of transparency, being able to understand how an algorithm makes a decision or how an AI-based model makes a decision, is getting more and more airplay. People are talking about it more and more. For example, as I said to you, the Defense Advanced Research Projects Agency, or DARPA, in the United States, which is basically the research arm for the American military, is doing a lot of research around explainable AI. Because the American military, for example, are using AI-based algorithms, to pilot their drones, to make decisions about recommending when a drone should basically, kill someone. If you're going to use these AI tools to make these decisions, you really want to understand how these AI tools are making decisions. So there's a huge amount of money that they're spending on what they refer to as explainable AI, or XAI, to really understand or provide transparency around how these AI tools are making decisions. Because it is a concern. If you're going to get an AI, if you're going to turn a decision, particularly about a human's life, over to an artificial intelligence tool, you really want to understand why it's making the decision that it is, right? And this issue of transparency and how algorithms make decisions governments are starting to legislate around it. Most people are familiar with the Gdpr regulation in the EU, which came out a few years back. They know that this regulation basically put a lot of rights to the consumer with regards to privacy and their use of data. A couple of little-known provisions in the GDPR, which had a huge impact in terms of the use of algorithms and AI, was this idea of right to non-discrimination and the right to explanation. And the idea here was that if the GDPR legislation basically said that you could not build an algorithm or an AI routine that made decisions about human beings based on certain critical criteria, for example, race, sex, age, these kinds of things, right? And it also said that if you're going to use an AI or algorithm to make a decision about someone, for example, whether they should get a home loan or not, or whether, you know, what their insurance premium should be or whatever, that you had to be able to explain it to them. They had a right to explanation. They had a right to understand why that home loan wasn't approved. Now, going back to my previous comments about the complexity of artificial intelligence tools and the fact that some of them are so complex, it's hard for us to understand how it's making a decision. If you think about it, this right to explanation in a lot of cases actually precludes the use of artificial intelligence or these complex algorithms, because if you can't explain it, then you can't use it, according to GDPR anyways. And this issue of non-discrimination, it's not the fact that people were putting in, racial background or, into the models they were using for the AI. It's the fact that there was unknown correlations between what they were putting in the model and these discriminatory factors. For example, one of the things that they were putting in the models was, for example, postal code or where you actually physically lived. But if you think about it, where you live is actually a good indication of your race. And so this is more about unintentional bias or people not understanding that if they're building these algorithms could be discriminatory, even though they didn't necessarily design them to be that way, because they're using factors which are tied back or relate back to or correlate back to, race, sex, these kinds of things. So the whole premise around this is that there's a process for these algorithms to become more transparent for people to understand them, right? This transparency, as you get more transparency, so this is kind of the crux of my whole presentation today. This transparency affects whether people accept these technologies or not, whether they are legitimate, considered to be legitimate. And so they have this process of algorithmic decision transparency that affects this process of technology legitimation, or people accepting the technology. And in between those two processes are these personal monitoring factors. These personal factors are human factors that affect the degree to which transparency affects people's perceptions of legitimacy when using a technology. And so a couple of concepts to think about, or a couple of premises here, is that, I'm maintaining to you that many of the concerns surrounding algorithms have to do with transparency. But remember, transparency doesn't necessarily always improve people's perceptions of particular technology. And so this transparency, depending on how it works and the type of transparency, and I'll talk about the different types of transparency in a minute, may either have a positive or a negative impact in terms of this technology legitimation process. And there are a lot of different factors that can moderate this process, and it's a complex process between these two, dynamics, between, how transparent is the algorithm in terms of how it makes decisions, and how legitimate do people perceive the process of using that algorithm. So, a few definitions. What is transparency, right? Well, it's a matter of information disclosure, this idea that conditions of transparency directly to quality, quantity of information, its transmission, the resulting degree of observability. It's a social process. It has social material aspects to it. The idea that increased transparency can improve insight and therefore accountability has been common and pervaded popular culture for years. However, if you go and look at the research, a lot of people would argue with this and say that more information, more transparency does not necessarily equal insight, and a lack of insight can mean, poor decisions or poor understanding. So, having more information, more transparency is not necessarily, improve people's views on governance of an organization. The other thing is, in some cases, as I said, more in transparency can actually lead to people believe in less in an organization, because once you pull back the covers and people realize how these banks and governments are making these decisions, it actually, in some cases, will actually freak them out when they realize how rudimentary some of these processes are. So this idea of algorithmic decision-making or AI transparency as a process, right? There are different types of transparency. So there's this idea of validation. Is it the decision that's being made by the machine? Is someone validating it somehow, somewhere, right? So that's a form of transparency. And there's different types of validation. You can validate the decision before the machine makes the decision, or you can let the machine make the decision, but then go back and check it, which is backward validation. There's local validation, so you can check to make sure that the machine is making a decision for that specific scenario. Or there's general validation, where you're validating that the machine is making the right decision across a variety of scenarios. And so this validation is part of this transparency process of validating that the machine is in fact making the right decisions. Another part of the transparency process is visibility. what degree is it, what is there an effective presentation layer that allows people to actually understand why these machines are making these decisions and how they're making the decisions? There's also this concept of variability. How important is this decision that the machines are being made? For example, I would say to you, there's a big difference between an algorithm in Spotify that decides what music to recommend to me versus the algorithms that sit in a nuclear reactor and decide when to shut down the nuclear reactor when there's a potential of an explosion, right? So, depending on that impact or the variability, that effect, right, that will have an impact in terms of the transparency process, right? People's perception of that. Experience. Human beings' ability to actually understand the outputs of this transparency process will affect how they think about transparency, right? And volition, the degree to which organizations are willing to give information to make these algorithms transparent. For example, some very famous examples, Google to this day won't show anyone what their algorithm is around Google search, and neither should they. But how is it that Google search algorithm making a decision on deciding which, articles to present to you when you do a Google search? Because if you think about it, it's very powerful, right? They're presenting you information, they're controlling how you pick up information, right? But they're not willing to provide that visibility. So this volition, this ability to, organizations to resist providing information about their algorithms is part of this transparency process. And, this value, the importance assigned to the underlying systems, right? Then I'll talk about legitimacy. So we talked about transparency, and I'll talk about legitimacy, and then I'll bring the two processes together. So legitimacy, this is this idea that it's a general perception or assumption that what an organization is doing, a government, a company, right, is considered to be desirable, properable, appropriate, right? All companies, all organizations, all governments operate in society. They have to comply to people's perceptions of societal norms. If they don't, people will take action, either through legal means or otherwise. This legitimacy theory has actually been around for quite a long time. It's been focused more on this idea of social and corporate reporting and social environmental issues, but now it's being applied more and more to how technology gains legitimacy, right? And so legitimacy theory talks about this idea, gives consideration to the expectation sets of various parties and the implicit social contract between an organization, society, and how an organization, attempts to gain legitimacy in terms of its practices, right? Because, and this is a process that occurs over time, organizations are constantly trying to demonstrate to people that they're doing the right thing because people's expectation sets change, and so therefore the organizations, how they respond have to change. And if they don't continue to do that, and then eventually again, people will take action, right? So organizations are constantly changing their processes and activities to, comply with social norms of the time. For example, as I said to you earlier in the presentation, this idea of reporting sustainability in a corporate financial report is becoming more and more popular. Several weeks back, ANZ Bank announced that they were going to start applying rules to governing loans based on the degree to which the organization applying for the loan was supporting sustainability. And that was because of activist shareholders at the ANZ Bank. So people are pushing, this idea that, people push societal norms, and people have to comply to that. And organizations have to comply to that, and companies have to comply to that. It's becoming more and more common. And the Gdpr regulation is an example of people, changing expectation sets, around privacy, how algorithms are used, and these kinds of things. If you talk about this process of technology legitimization, how did technologies gain legitimacy? You actually have to define legitimacy and get into the different types of legitimacy. And there's sort of three generally accepted types of legitimacy. The first one is what they refer to as pragmatic legitimacy. This is legitimacy gained on the part of an organization's constituents. So for example, it's shareholders, it's customers. So people may be pragmatic and say, you know what, I'm accepting the use of this technology or this AI tool. I'm a bank and I'm accepting the use of AI to detect fraud because I know that the bank has, I'm a shareholder of the bank and I know that the bank has problems to detecting fraud. So I accept it because I'm a participant in the, in that organization. Moral legitimacy, this is this idea that, society has, expectations, norms, does this technology have, comply to those sort of morals that generally, espoused in society. And probably the third and most interesting type of legitimacy for me is what they refer to as cognitive legitimacy. To put it simply, this is the taking for granted nature by society. To what degree do people take for granted the use of technology, right? Because everyone walks around with mobile phones, now everyone takes a mobile phone for granted, but it wasn't always like that. So, you know, this taking for grantedness aspect of technology is pretty critical when we talk about the technology legitimation process, or people accept technologies. And there's a pretty well-defined process for technologies gaining legitimacy. And it generally goes like this. Someone comes up with a new idea, new technology, right? They think, hey, this is a great idea. I think I can apply this in a few areas. They then look to try and find a specific local, you know, example where they can apply that technology. And because it's a new technology and people might not accept it, what they tend to do is bundle it in under another project or another activity, right? So it doesn't get challenged. And then they put that technology in with this other project. And then when the project uses that technology, they go, hey, see, it's being used, right? So that's local validation. Then what happens is it slowly just starts to get diffused, and you see more and more pockets of that technology being used in various areas, right? This is this concept of diffusion. And then all of a sudden you get this general validation where everyone's using the technology in all these different spots, and you get this cognitive legitimacy where everyone sees, well, he's using it, they're using it, she's using it. Well, it must be, you know, it's just normal, right? I'll accept it because everyone's doing it, right? So I might as well be doing it. And there's been some really classic examples of how this technology legitimation process works. For example, indirect potable water reuse in the United Kingdom. So this is the idea that what comes out of your toilet is processed and used as drinking water, right? So you're reusing the water that comes out of the sewage and putting it back in as drinking water. Probably, you know, when I describe that to you, you don't know, that's a pretty gross concept. But the reality is, for example, in the UK at the moment, a lot of cities, in fact, the majority of cities are using some form of IPR to provide drinking water or supplement their drinking water. Now, 10 years ago, very unpopular concept, but what happened? This legitimation process, a few people came up with some technologies to allow the use of basically toilet water has become drinking water to process it. It was applied to a few specific municipalities, right? When those municipalities saw that other municipalities saw those municipalities using it and people weren't complaining, they kind of took it for granted, and it started to diffuse across the country. Well, now it's one of the primary, you know, it's a very common tool. So even very distasteful concepts through this technology legitimation process can be adopted. So this is kind of in a slide, this whole, you know, transparency, technology legitimation, and these personal monitoring factors, right? So I said, you know, you get transparency through validation, you get transparency through visibility, you get transparency through variability. In other words, you know, understanding the degree to which these decisions have an impact on people's lives. There are personal monitoring factors that affect the process of transparency. For example, people's willingness to give up the information, their ability to understand the information. For example, you know, an airline pilot that observes a automated pilot because they have specific training, they can understand what that the algorithm or automated pilot is making a decision, so it's easier for them to understand the value or the importance of the impacted system. And then this process of legitimation, where, you know, you get this pragmatic legitimacy, people taking for granted, moral legitimacy, is it the right thing to do? Pragmatic legitimacy in terms of, you know, people accepting it because they're a stakeholder, moral legitimacy because it's the right thing to do, and cognitive legitimacy because it's this taken for granted nature by society. So all that being said, let's boil this down to some practical learnings of things that organizations should consider when they're trying to get people to accept the use of algorithms, to accept the use of artificial intelligence in their organization. The first thing is to understand, the first thing you have to understand is that the improper use of ADM or AI can have an impact on your organization. It can have a significant brand impact, right? There's lots of cases of where people have been using AI tools. Those AI tools have made bad decisions. It got out to the press and people didn't like it. Regardless if there is a legislation saying you have to do something or not, like regardless of whether there's a GDPR or there's no legislation in your local geography that governs this, the reality is if you make bad decisions using these algorithms or these AI tools, right, you're going to be judged. You're going to be judged by the public, you're going to be judged by governments, you're going to be judged by your customers, you're going to be judged by your employees. So the first step in this process is to recognize that it's important that you understand it. Because those business managers that kind of say, oh, we're going to use these tools and I'll give it off to the tech guy and let him deal with it, they're the ones that come undone because the tech guys do what they're doing and either, you know, knowingly or unknowingly make mistakes, and then that impacts the business, and then, you know, stuff happens, and then, you know, the business manager has to get pulled in because, you know, people are upset. The next thing the thing about this idea of transparency is to recognize that it does have an impact in terms of how people perceive your use of algorithms and artificial intelligence. It's not always positive, right? It's a complex process. So just recognize that you have to think about transparency, to what degree you're fronting up about how you're using these technologies, and recognize how you're going to address that transparency issue when you're starting to deploy them in your organization. Also recognize, as I said, that depending on the geography, it may be legislated that you have to be transparent. If you're in the EU right now, European Union, and you have algorithms that are making decisions about people, you may be breaching the GDPR. If you're an international organization that has divisions that work in the EU, you may be breaching the GDPR. So you need to understand, what the local regulations say about the degree to which you need to be transparent about how you use these algorithms. Also understand that there's different forms of transparency. How do you get an algorithm to become more transparent? For people to understand that there's this issue of validation, there's this issue of visibility, there's this issue of variability. These are all different factors that go into making something more or less transparent. So if you're going to, try to address transparency in terms of your use of algorithms or AI, you need to address these different factors. And recognize that there are many different paths for an organization to get to in terms of making a technology more legitimate, right? And that there's different forms of legitimacy: moral, pragmatic, cognitive. And there's different paths to get there, but it usually starts out with a sort of local process, this diffusion, and then this idea of general validation. So just a few things to think about when you're deploying these technologies in your organizations from a transparency perspective. And then just some general conclusions. Like I said, algorithm decision making and artificial intelligence, they're becoming used more and more just because we have all this volume, velocity, and variety of big data. Because it's overwhelming us in our everyday lives, and we need these tools to help manage things. But as I said, with the increasing pervasiveness of algorithms and AI, there's a lot of concerns, and organizations, governments, and corporations need to address these concerns. The need for transparency around algorithms and AI has become part of the general discourse. There's a lot of research going on in this area. There's a lot of government regulations coming out to manage it. It's something that all organizations have to think about, and they have to fold into their business plans when they're using these types of technologies. As I said to you, transparency has an impact on people's perception of the legitimate use of these technologies, but it's a complex process and can be both positive and negative, and there are monitoring factors that affect it. We talk about the different types of transparency: validation, visibility, variation. And I talk about this idea that transparency is a process. It's not an instant. You don't just make something transparent, therefore people accept the technology, and it's something you have to work on constantly. From an organizational perspective, you have to report on it, manage it, and make sure things are dealt with. And that was it. There's a lot of concepts that I covered in the last 45 minutes. It's relatively complex. I apologize for that, but I mean, hopefully you found it a bit of an interesting conversation. This idea of transparency, as I said, in AI and algorithms is, definitely becoming more and more talked about. So hopefully you find this interesting. As I said, here's my contact details. You can use a QR code to connect with me on LinkedIn. And yeah, I'm happy, Nadia, if we want to see if there's any questions from anyone.
Perfect. So I think you must have answered a lot. We do have one question. What's actually more of an ask. They do want the link to your research paper.
Yep.
If that's okay. So I mentioned we can pop that link into.
Yeah, I don't have it handy on me. I'll have to give it to you guys.
Okay, cool.
I know I said that, and I realized as soon as I said that, I'll do that.
I think it was one of the first questions that came in was, could we please have access to that research paper? Yeah. But David, if you want to send that research paper link to me, and then I'll be more than happy to pop it into the meetup event. That way you'll have access, and I'll also have the recording of the session up there as well. But other than that, I think that was the only question that they had for you tonight.
Cool. All right. Well, hopefully people found it interesting, and yeah, please feel free to contact me.
I'll do a very quick update just on the Reactor events that are up and coming. If you do have any last minute questions, do ask them now before we do end the session. So thank you to those who joined us today. If you do want to join our community, you can find us at meetup.com/Microsoft Reactor Sydney. That's where I post a lot of our video content and a lot of the presentations that are asked for during the session as well, if we don't have them handy on the night. You can follow us on Twitter, follow us on our YouTube as well. I have popped the link in the Q&A for you to be able to go back and watch the session as well. And you can follow us and send us an email to reactorset@microsoft.com if you've got any questions about the Microsoft Reactor or you're really keen to get involved. I've also popped a link in the Q&A if you do have any feedback on tonight's session. We really do appreciate the feedback that you give to us, and we do pass it along to our speakers as well. We do have an event coming up next Tuesday called CI and CD and Beyond with GitHub Action. So that's going to be delivered by one of our cloud advocates, Damien Brady. So that'll be a good session. There'll be more information on our meetup as well. And we are officially doing a second Power Apps for Big Kids and Little Kids as well. We went really well with the very first session. We had about 50 people join the call. We got kids really excited about Power Apps, and now they're doing a little competition for Christmas as well. So feel free to RSVP to that for your children on the 21st of November. So no more questions have come. Oh, hang on. I think we have one. Oh, David, we do have a question for you.
Mm-hmm.
Do algorithms get audited before they're deployed? Is there such a process?
Well, so that's what I was referring to as forward validation. It depends on the organization. The reality of it is, like I said, in some places like the EU with the GDPR, those legislations are starting to push people to do that. But this is one of the challenges, particularly with AI now, and particularly that algorithms are making more and more decisions. To what degree are people required to validate the decisions that they're making? So there's no sort of audit. It depends on the industry, the government, all these kinds of things. But it is something that organizations have to think about.
Cool. We've got another question that's come through as well. How do we make the algorithm bias proof? Like the algo became biased because of the postal code.
Yeah, so that's the reality of it is bias is an easy problem to solve, right? Because there's a lot of statistical techniques that you can use to reduce bias, to identify that bias. It's the unintentional bias that's the problem. So part of the issue is the technologists not understanding that there may be bias in the data that they're producing. So there are a lot of tools and techniques that people can use mathematically, statistically, to identify bias, to address those issues. The problem is people don't use them. So you can't. So I mean, the thing is, I can take bias out of a machine. It's really hard for me to take bias out of a person, right? And we all have biases. So I think the first step there is actually recognizing this issue of unintentional bias, and then using the appropriate tools and techniques to identify when you have been using bias in your data, and making sure that your data sets are representative, right? So it's something to do. It's just people don't think about it. That's the problem.
Cool. Well, I hope that answers all of your questions. That seems to be it for us, David. So thank you all for joining. Thank you so much, David, for coming on and taking us through as well. And we're really looking forward to seeing that research paper as well that you've done.
Okay, I'll push it onto I'll give it to you. You can put it on the meetup group. Okay.
Sounds good. Thanks, David. Thank you, everyone. Have a good night, and we'll see you all next time. Bye for now.